Section 1.5, we're talking about scales. So my bobblehead, if I had one, is a 1 to 13 scale model, which means that the handsome little devil, this must be a man who wrote this lesson, is 1/13 of my actual height. So my mini-me, the bobblehead, is 5.82 inches tall. How tall am I? So if we take 5.82 and we want to go larger, okay, because he's going to be taller than his bobblehead, I would certainly hope. So to go larger, we're going to put 13 on the top. Multiply by 13 to 1, because that's going to help us get a bigger number. Gives us 76 inches, or 6 inches, or 6 feet, 4 inches. So, pretty tall dude. If the actual mini-me, I'm assuming he's talking about his son, had a bobblehead at the same scale, how tall would it be? And so his son must be 32 inches tall. And we want to make a bobblehead of him. Well, this time we're going smaller. So we're going to multiply by 1 to 13. The bobblehead would be 2.46 inches tall. So let's write a process for this. If we're going larger, then we're going to multiply by 13 over 1. That takes us from the model to full size. If we're getting smaller, going from full size to the model, make sure that's an L this time, we're going to multiply by 1 over 13 because we're getting smaller. Okay, looking at this map, it indicates that 1 inch on the map corresponds to 2,000 feet in real life. So 1 inch is 2,000 feet. That's what's shown in this little bar right there. It says points A and B are 4.06 inches apart on the graph. So mine doesn't look like that, but I'm sure my picture got smaller, and I'm sure your picture is even smaller than that. But anyway, how far is the casino from the golf course in feet and miles? Okay, so we know that 1 inch is 2,000 feet, right? So we have 4.06 inches, and we're trying to get bigger. So we're going to multiply by with the 2,000 feet on top. Notice how this cancels out inches for us, okay? And we're just left with feet. So 8,120 feet. Wants us to also go to miles, because we usually don't talk about a distance we're traveling in feet. And I'm going to tell you that there are 5,280 feet in a mile. So if we multiply by 5,280 feet in 1 mile. Now, why did I put the 5,280 feet on the bottom? Because that's what's going to allow my feet to cross out. So it's important you pay careful attention to that. Then we get 1.54 miles. So apparently it was not very far. If we look at a satellite photo in the same picture, could we see any boats on the river? Let's say we have a 50-foot boat on the river. How big would it appear in the photo? And do you think we could see it? So if we have a 50-foot boat on the river, how big would it be in the picture? So it's going to get smaller, right? So we're multiplying by 1 inch over 2,000 feet, okay? Because we're getting smaller. And that'd be 0.025 inches. So, yeah, it's probably too small for us to see on the picture. Write a verbal description of the process like we did in the other one. So if we're going larger, then we're multiplying by, or excuse me, yeah, let's do that. Write this a different way. So if we're going from real life to map size, then we're multiplying by 1 over 2,000. And from map size to real life, we would be multiplying by 2,000 over 1. So, conversion factors are what we use to change sizes here. So if we want to go from 22 feet to inches, let's think about, remember I said, why did we put this on the bottom a minute ago? What if we multiply 22 feet by 1 foot is the same as 12 inches, or 12 inches is the same as 1 foot? Okay? Now what does that give us in units? Well, here we have feet times feet. Feet times feet would be feet squared on the top and just inches on the bottom. Here, the feet cancel out, so we're just left with inches. So that's why when we're going from one to the next, we have to make sure that if one unit's on the top, then that same unit is on the bottom. Or if the unit's on the bottom, then that same unit is on the top when we multiply. So how many inches is 22 feet? We would multiply by 1 foot, goes on the bottom, is 12 inches. And again, that cancels out our feet. And it's 264. Don't forget your units. We're left with inches. Let's say we want to convert 3 miles of driving distance from the map into yards. First, your conversion factor was 1 mile was 5,280 feet. So taking 3 miles we'd put 1 mile on the bottom so that the miles will cancel, and 5,280 feet on the top, and we get 15,840 feet. Now, what if we want to take it to yards? Well, we have 15,840 feet. And how do we get to yards? Well, we know that there's 3 feet in 1 yard. So we would multiply by 3 feet on the bottom to 1 yard. That gets rid of our feet. But what's happened here is we've got the 3 on the bottom here. So we can multiply by 1/3, or we can divide by 3. And that gives us 5,280 yards. Yeah, because of the 3 in there. Okay. What if we want to convert 3 miles directly to yards by doing a 2-part calculation? Okay, same type deal. It's just this time we're going to take our 3 miles and multiply by the fact that there's 1 mile, or 1 mile is the same as 5,280 feet. And then in the same line, we're going to say, well, we know that 3 feet is 1 yard. And so here, miles cancel out, feet cancel out, and we're still given the same answer, 5,280 yards. So it may be easier or quicker for you to do it this way, whatever way works for you. So far we've looked at lengths, but we can convert anything with scales, including measures of volume. So in this case, we want to change 2 liters. It says use factors in the table to find how many cups are in a 2-liter bottle of Dr. Pepper. And by the way, this is important. There is a list of conversion factors on page 64 in your book. Now, I may provide you one too, but there's definitely one on page 64 in your book. Okay, so first of all, we're taking a 2-liter bottle and we're converting it to cups. Okay, so over here we need to find liters. And we don't have anything that says liters to cups. But we have liters to quarts. That might be helpful. And then, could we go from quarts to cups? Well, no, but we could go from quarts to pints. And then, I think we can go from pints to cups. Let's see, yes. Okay. So the first thing we'll do is we've got that 1 liter is 1.06 quarts. Okay? And then we have that 2 pints is 1 quart. So 1 quart is the same as 2 pints. And last we have that 2 cups is 1 pint. So 1 pint is 2 cups. Okay? Okay, so liters cancel out, quarts cancel out, pints cancel out, and we're left with cups. So what have we got to do here? It's just ones on the bottom. So we're doing 2, just put this in your calculator, 2 times 1.06 times 2 times 2, and we get 8.48 cups. Sometimes scale is described in terms of percentage. For example, the filming of the Academy Award-winning film Titanic, a model of the stern of the ship was created at 12.5% of the actual size. So a section of the rail on the stern of the real Titanic is 24 feet long, or was. I guess it is. It's still down there somewhere. How long was the corresponding section on the model used for the movie? So we need 12.5. Oh, cat just landed on me. Sorry. 12.5% of 24 feet. Okay? Change that 12.5 to a decimal. So 0.125 times 24. And that tells us that this section of rail for the model was 3 feet. Okay? If an I-beam on the model spanned 30 feet of deck space, this was a big model, how big was the corresponding I-beam on the actual ship? Okay, so we need to know 12.5% of what is 30 feet. So remember back when we were doing percents, change the 12.5 to decimal, 0.125 of what? So times x is 30 feet. Divide both sides by 0.125, and so the actual size of this I-beam was 240 feet. Last, could we create a scale for this? Well, if 12.5% is the size of our model, we know 12.5 goes over 100, that's a percent, right? Let's move the decimal over. And that's the same thing as 125 over 1,000. And we need to simplify. So divide the top by 25, divide the bottom by 25. Because we know that 25 will go into both. And we get 5 over 40, but looks like we can get smaller. So divide the top by 5, divide the bottom by 5. And we have 1 in 8. So the scale from the model to the actual ship is 1 to 8. Forensic scientists often examine scaled-up crime scene photos to search for evidence that might be hard to see at regular magnification. Studying bite marks on a photo of a victim's leg at 500% magnification, a technician measures the distance between 2 punctures from the bite to bite to be 165 millimeters. What is the actual distance between punctures? Okay, so we know the magnification is 500%. 500% is the same as 500 over 100, or 5 to 1. Okay, so we've got 165 millimeters on the photo. And the photo is bigger, so we're going smaller. So we're going to multiply by 1 over 5. So the actual size between these bite marks is 33 millimeters. In the 1984 movie Ghostbusters, a 112.5 foot tall Stay Puft Marshmallow Man. Have y'all seen this movie? This movie used to scare me when I was little. Just one part of it. The only part that scared me was when the librarian jumped out. And I would hide behind a chair and I'd be fine for the rest of it. I don't know why. So, anyway, the Marshmallow Man goes on a murderous rampage in New York City. After the film's successful box office run, a 20-inch replica of the big guy was sold in toy stores. What scale was being used to make the replica? Okay, so we have 112.5 feet for the actual Stay Puft Marshmallow Man. And we know, the first thing we need to do is change this to inches, okay, because we're going down to a smaller size. So we know that 1 foot is 12 inches. That's 1,350 inches. So our scale must be 20 inches for the smaller, 1,350 inches for the larger. If we reduce that, that's 2 over 135. So written as a fraction, our scale is 2 to 135. Written as a decimal, my cats are wreaking havoc right now. You can probably hear them running around. I'm sorry about that. And that's a toy bird. Oh my goodness. I should have locked myself in a room, but then they would have just scratched at the door. So a decimal would be 0.0148, and as a fraction, move the decimal over 1.48%. Okay, last one. Then I'm going to go round up some cats. Doll houses provide an excellent example of scale modeling. The 1/2 inch scale is very common for doll houses. This means that 1/2 inch on the dollhouse corresponds to 1 foot for life-size objects. Make sure you clearly show, calculations. What is an equivalent ratio form for the 1/2 inch scale as described above? So we know that 1/2 inch is the same as 1 foot. Well, the first thing we need to do is change this to the same units, okay? Well, actually, what we'll do is get rid of the units, okay, to make our scale. So we know that there's 12 inches in 1 foot. Notice our units go away altogether. And so if we multiply here, we've got the 1/2 inch there times 1 over 12 here. That's 1 over 24. And lastly, it asks us to write it in a ratio form. We could also write that as 1 to 24 like this.